Okay, so moving on a little bit from solving equations for a minute, we're going to talk about ratios, rates, and conversions. So in this lesson, we're going to talk about ratios, rates, and then we're going to be converting units and rates. So first, talking about comparing unit rates. And a unit rate is a thing, or a unit like miles per hour. It's a number over another number, a unit over another unit. So it's like a fraction where you have 60 miles per hour. You're traveling 60 miles. I'll do that better. 60 miles every 1 hour. So it's a ratio of 2 units where the bottom unit is just 1. Okay, so 1 unit. So to compare unit rates, it says you're shopping for t-shirts. Which store offers the best deal? So store A is a unit rate. You would take the best deal would be the lowest dollars per shirt, per one shirt. So store A would be $25 for 2 shirts, which would be $12.50 per shirt. I'm just dividing the price by the number of shirts. $45 for 4 shirts. You take 45 divided by 4. That's $11.25 for each shirt. And then store C, $30 for 3 shirts. That would cost you $10 a shirt. So the store that offers the best deal is store C. It offers the lowest price per shirt, the best deal. Okay? So moving down to guided practice 1 down here. I'll go through this one with you, but it says the prices for 1 shirt at 3 different stores are shown at the box at the right. If store B lowers its price to $42 for every 4 shirts, which store would have the best deal for 1 shirt? So let's just look at store B's changed pricing. Okay, so right now store C is the cheapest. I'm going to take $42 divided by 4. This would cost $10.50. So what that means is store C still has the best deal. It still has the lowest unit price of $10 per shirt. Still has the best deal for each shirt. That didn't change just because store B lowered its price. It only lowered it to $10.50 per shirt. So store C still has the best deal. The next big idea of this lesson is converting units. So we've got to know a few things about certain units. So we have to know there's 60 minutes in an hour. So if I'm converting 330 minutes to hours, okay, I've got to know that my number for hours is going to be less than my number for minutes, because there are 60 minutes in 1 hour. So when I convert this, I'm going to take my 330 minutes and I'm going to multiply by something called a conversion factor. So a conversion factor could be there are 60 minutes in 1 hour, or there is 1 hour for every 60 minutes. So essentially I'm asking myself, to convert minutes to hours, do I multiply or divide by 60? So to convert minutes to hours, I'm going to divide by 60, which means I'm going to use this conversion factor. And kind of what I'm thinking about is I'm going to eliminate the units of minutes to convert them to hours. So I'm going to divide out the minutes here to eliminate that. This becomes 330 hours divided by 60. And I just use a calculator to help me figure out what that is. That's 5.5 hours. Okay? So it's first of all understanding the units and how you would convert, and predicting, is the result going to be bigger or smaller than your original number. For part B, converting 5 feet 3 inches to inches, the thing I want to do here is I want to convert feet to inches. Okay? So that's me knowing I have 5 feet. I'll worry about that extra 3 inches in a minute. But converting feet to inches, that means I'm going to have more inches in my answer than 5 feet, because there's 12 inches in a foot. So my conversion factor here, I want to multiply by 12 inches over every 1 foot. Feet on the top, feet on the bottom. These units essentially eliminate, and I do 5 times 12 divided by 1, which is really just 60. Okay? Sorry, not 60 feet. 60 inches. So really my answer to this, in the end, is 63 inches. So when I convert, I've got to understand, when I get the units, am I going to get a bigger number or a smaller number than when I started with? You are essentially only multiplying or dividing to convert units. That's it. But you have to understand when to multiply, when to divide. So that's what you could practice in eventually. For the guided practice number 2, I will let you work on that one on your own. I will write out the conversion units for centimeters to meters. There are 100 centimeters in each meter. So I can do 1 meter over 100 centimeters, or 100 centimeters for every 1 meter. Take a minute to pause the video. See if you can convert this. You're just thinking, do I divide or do I multiply by 100? So in this case, I'm going to divide by 100. I wrote 1,000 here on accident. Divide by 100. So if I divide 1250 by 100, that's going to be 12.5 meters. And that should make sense because there's 100 meters in a centimeter. Well, going from a smaller unit of measure to a longer unit of measure, that's why I would divide. So just knowing when you divide or when you multiply. Okay, so for example 3, the CN Tower in Toronto, Canada is about 1,815 feet tall. How many meters tall is the tower? So we're going to use a conversion factor, conversion rate, 1815 feet. So when I'm writing this factor out, I know 1 foot or 1 meter is 3.28 feet. 3.28 feet. I don't know if I said 328. 3.28 feet. So the way I would set this up, I would write out my factor as 1 meter over 3.28 feet. So I'm dividing in this case. And if you don't know, when you have this factor given, if feet are given, you want your feet to be on the bottom of this factor so that they can eliminate. So in my calculator, I'm going to take 1815 divided by 3.28. So about how many meters tall? It's about 553 meters tall. I know it goes to 553.35. We can just round it to the nearest whole meter. So I'm going to give you a similar example for number 3. Great chance for you to pause the video to practice. Okay, so for example 4, you're converting a rate, which a rate is a ratio with 2 units. So in this example, a student ran the 50-yard dash in 5.8 seconds. So I'm going to write a ratio of 50 yards over 5.8 seconds. What I'm asking you to find is the speed they ran in miles per hour. So we're going to use this to convert yards per second to miles per hour. So the easier of the two, I would think, to convert is seconds to hours. So we're going to set up a ratio or a fraction to go from seconds to hours. So before I go from seconds to hours, I want to go from seconds to minutes. So I'm going to use the fact that 60 seconds are in 1 minute. And those seconds units cancel or eliminate. So you can do this one of two ways. I'm not going to do any of my multiplying until the end. So I'll show you what I mean as I go through the example. So I went from seconds to minutes. Now I'm going to go from minutes to hours. And I'm going to use the fact that there are 60 minutes in 1 hour. So I write that ratio. And the minutes eliminate. So at this point, you could convert all this. You could do 50 times 60 times 60. So 50 times 60 times 60 is 180,000. So I'm going to eliminate that. 180,000 over 5.8. So now the 5.8, the seconds. I know that seems weird, but I'm going to write this as hours. And I'm going to write this 180,000 in terms of yards. So I didn't really convert quite yet, but it's just getting the numbers down so that now I can convert, or the units down so I can convert yards to hours, or yards to miles. So it's using the fact that 3 feet is 1 yard, and there are 5,280 feet in 1 mile. So I've got to do a couple more conversions. So first I'm going to go from yards to feet. So I'm going to use the fact that there are 3 feet in 1 yard. That gets the yards units to cancel. And then I'm going to convert feet to miles. So now here, I'm going to put 1 mile on the top and 5,280 feet at the bottom. Because I want miles, I'm not eliminating miles. So I know I wrote a lot here, but with just this section of what I've got for my work. I'm going to multiply all the top numbers by each other, and then all the bottom numbers by each other, and then I'm going to multiply or divide the top by the bottom. So I'm going to take my 180,000 times 3 times 1, which is 540,000. So big number. And I'm going to divide that by 5.8 times 1 times 5,280, which is 30,624. And that's in terms of hours. So I'm going to take my top, 540,000, divided by 30,624. So the speed the student ran in miles per hour to the nearest tenth would be about 17.6 miles every hour. So converting a rate forces you to convert two units at the same time. So it takes a lot more work. So what I'd like you to try is I'd like you to try number 4 on your own. Good chance to pause and then just check the answer at the end. So in this, I'll write again that 5,280 feet are in 1